All right, hello, hello, hello. Back with some more sub work here. Did some work whilst at work. Changed over to some turbines. We'll see what happens with that. I may or may not keep them. Let me just fill out a message here. So we got some really good speeds out of the sub using turbines. How's it going there, Thermite? And then started working on a crane. Got really good speeds. Started working on a crane, and then the devs updated. Let's go look at the update real quick. So that was good. Kind of waiting for that update, see what they're going to do. So here we go. It's the hydrogen fuel cell and space mining update. They added a hydrogen fuel cells and lunar mining on the moon for DLC owners. The mine is for hydrous ore. You can also use oxygen and hydrogen for making a hydrogen fuel cell. So we're going to play with that, see if we can add that to the sub in some form or function. But put in some turbines. I would have liked to keep pistons, but we'll see. Currently, we have a lot of turbines in here, as you can see. They pretty much go down the whole wall here, but we got really, really good speeds. So let's go take it for a speed run, and you can see how fast I'm able to get this sucker going with that. Started to work on a crane so that we can load up. I'm going to play with some designs on that. That's an important feature, so to be able to load stuff on containers and whatnot. So change the design of the stern a little bit, make some more space back here. So just a bunch of stuff. Play with a bunch of design choices here and see what we can come up with. But nice, good speeds. I think we're like 137 and 150, or 37 knots surfaced and like 50 something knots submerged. I don't need or want it to be super duper fast, but it's kind of nice to have a little bit. You know, I kind of like the pistons. We'll play with them, see what we can get. Turbine's probably more accurate, but we're getting good speeds off of them. And, you know, I want to have hallways down the sides here. And what we'll do is we'll be able to put a catwalk on top of the turbines, which I think will be even more cool. Kind of walking across the top of them and then coming down into the reactor room. I think that's would be kind of a cool thing. And then I'm trying to see if I want to reserve some space in the back here for to be able to launch a sub out of the rear of the main submarine. So, a bunch of things. You shall see soon, Thermite. You shall see soon. They're reasonably loud, but they're not, like, I don't really care too much. They don't bother me too much. Alright, well, let's see where we're at here. We should be pretty close to... I've been playing on my laptop too much. I'm reaching for the function key, even though there's no function key. Pretty loud. Yeah, they're pretty loud. So that's, we got a pretty good cruising speed here. So right now we're doing 35, 36 knots. Above. Squared off a little bit more than I like, maybe in the back, but again, I want to make. I might put a submarine under there. I might not have clicked the ballast water up in the ballast tank, so let's see where we're at now. Yeah, I was doing 50 something in my testing, so. But once we get, like you can hear it's much less loud now because we have it under load. Hello, Rasmus. Yeah. There's things I can do, for example, keep them under load, which will help. But I have really good speeds here, so let's bring it back. I'll show you I started work on the crane. Try to decide if I want to put it in that cubby or not. So here's the crane, just kind of a rough crane. Just kind of show you what it does. So the first element needs to come up like this and lock in a position so that it will come out of there. I might put a smaller crane on the elevator. That's another thought. And then you've got, crane. So I have pictures. I was able to easily, lift a container from long distance. So shouldn't have any problem getting a, kind of a crane figured out for what I want to do. So one thought I had was to put it in this cubby here and then have it come out. The other one is put it on the elevator and have it rise up with the elevator. So haven't quite decided how I want to do it yet. So we'll kind of figure that out, what I want to do. So let's play with the new, let's play with the new components. We have that update, so test those out. Good to see you, Thermite and Rasmus. Let's see. So here's the new part. Hydrogen fuel cell capable of generating electric power. Pumping hydrogen and oxygen into the fuel cell generates power while creating water as a byproduct. All right. So we need, let's see. So we got oxygen, hydrogen in, water out. Okay. So let's do a quick test on this. So that's that. Okay. And what's it making? Electricity, right? Okay, good. All right, so there's that. So I'm not going to create a loop yet. Is there any on-off function at this at all? No, just pretty much it makes. Okay. So does it need pumps? Let me see. Might need pumps. I don't think it would need pumps because it has them hooked up. Make sure I hooked them up correctly. That's why they're backwards. All right. All right, now we've got electricity, so let's do... All right, good. So we're keeping our electricity there. All right, good. That's still making, so where are we at here? 13 S-watts on the way out, okay. So we can go big in that. Oh, have you? Very nice. Did I see your new aircraft? Let me look. Sometimes I look at them and I see them and oh, I did see that one. Yeah, that's looking good. The cargo plane, yeah, that's neat. I likes it. I likes it. It's a cool looking new truck too. Let's go bigger. Yeah, is that another thing people have been asking for a while? Some sort of way to turn hydrogen into power, and again, it's like one of those things that people like will never have, and it's like eventually if they have time, they'll do these things if it makes sense. They'll not do everything, but like the people who said the game was not getting updates ever again and all that silly bullshit, like get hit in their ass, frankly. All right, let's go ahead and check this one out. That is is it losing electricity? No, it's pretty much keeping it. Let's see. That's pretty damn good. That's 131 S watts with one electrolyzer, or with one fuel cell. That's not too bad. Yeah, it's not massive quantities, but again, you could probably stack these up. So let's they didn't get water outputs. Okay, I gotta put those water ports on. Yeah, especially this would be good for the sub just to make electricity. How's it going there, Sergeant? Like, this is good for passive electrical generation in ships, because you pretty much put a hydrogen electrolyzer in the water and just run it. Let's see. Yeah, see, these are gaining electricity now, and let's see where we're at. Oh yeah, that's pretty damn good. That's 1/10 of the S watts that one of my power plants was able to make for my submarine with 3 of these Johnnies. That's pretty damn good. You know, and it's pretty easy to store this. Like, you can store the gas for extended periods of time. That's pretty damn good. Screw up some electrical connection, probably. Not merge it. Yeah, I didn't merge it. Alright, we'll do it. I screwed up electrical connection too, I'm sure of it. Yeah. Let's do this the right way too. Alright, that's all plugged in. I'm going to run some different ratios, trying to see what best efficiency we can get, but because the most you can be able to go is 19 RPS on an electric motor. So, you know, that's the top out. of it. The only thing you can really play with is the efficiency of it, and you can do that with some gearing. So like right now we're not high enough on the RPS, so like down gearing doesn't make any sense. So if we go ahead and press a down gear, you see all it's doing is it's reducing our generation. But if we go to up gearing, we're going to get from 17 to 19 likely, and that's going to give us more power. But, you know, the benefit of down gearing is we use less electricity. So. All right, good. So that's looking pretty capable of a system. Like, it's pretty compact. You know, able to move a large motor running a large generator, which is pretty impressive. Yeah, so about 394 with this current setup, and we're currently at 100% electricity, which means that we could move more generators essentially, or gear it up. That's pretty good. I want to test something out. I want to see what the RPS is on the... I don't like these pitchable propellers for this application. Really don't. I'm gonna run the, I want to see what the RPS is on these real quick. No, it's so nice not playing on my laptop where I have to like press function keys to get home and page up and everything. Very nice. I know it's a little dark in this engine room. I'm trying to lighten it up a little bit. This fires up pretty fast now. Ideally, I would still like, prefer the pistons. There's a bunch of things I can try too. I'm gonna test out some electric motors. Doubtful because the electric motors are limited to 19 RPS, so I really can't. it's tough to get the props to go the speed that I need them to go with electric. I was thinking of a hybrid system. That's a thought. We got a bunch of different ideas how I want to run this. So I like these propellers better. I would probably like to use these. We'll see how I want to do this. So let's go back down and see what I was trying to check out. Alright, I want to check out the RPS at the end and see. So we're looking at 35 RPS. And we lose a minimal amount of speed by upgearing it a little bit. So we lose a couple knots, but it's much, much quieter in here. We still get the 38, but all we're doing is we're trading off turbines. So like the turbine is only spinning at 4 now, so it's nice and quiet. Now, so let's look at this. So we're doing 33 knots. So you hear the turbine spinning up, and we're getting... The turbine's loud because of that 35 RPS. Yeah, we gotta check the speed too, but... So at 35 RPS, we're getting about 30 knots. And now the turbines are quieter, we're doing 34. And the turbine is now spinning at 13. We go up another one. The turbines are very quiet. We're still doing about the same speed, but the turbine is now going slower. So the turbine's down to 4 RPS. So, like, if you're having problems with the turbines being too noisy, you can trade off that. And the same thing with the jet engines. You can trade off getting the jet to go slower and then turn a bigger fan, essentially. That's why, like, modern jet engines are a lot quieter. You turn a bigger fan, slower, less bypass. Now we're down to 30, so we've lost some speed here. But if you look, we're down at 1.45. So if your goal was to get your turbine speed quieter, you could do that. So still about where I was at before, a 9-to-1 gear ratio. And I could fine-tune the gearbox to check it, but about a 9-to-1. So 33 knots is pretty good. And then what I'll do is I'll control speed with steam pressure, essentially. So I gotta play with that. And then what I think I'm going to do is, let's see, we got a 9 to 1. If I did a 5-2. 5-2. Be 3 times 5, 15 would be a 7.5 to 1. Which one's that? That one is this one. Okay. That's 25 divided by 4. 25 divided by 4 is a 6 1/4. Okay. So that's good. And then I want to put in a braking system and a reverse. At some point. I don't need to do it right now. And where's steam in? That is steam in. So this is the steam in pipe. So what we'll do here is we'll put 2 variable valves in here. All right, so that will be our actual speed control will be there. I should be able to get rid of the clutch if I do that. I'll still probably leave the clutch there for reverse. Let's do this. Starting to get to the point where I can start working some drive systems here. All right, so that will do that, and then for the clutches, what do I want? I'll do one here. Oh, that should be all right. And then I want to change this to be slower. About 10% there. All right. So the other thing I was thinking is if we have enough power to double up the propellers, because what I was thinking of doing is doing a ducted prop system and then having 1 forward, 1 reverse, and then I can do 4 props, but I'd have to play with that. See if I actually get more speed off, or more speed off 4 props. Let's play with the thrust system, see if I can get good thrust control out of this. But I'm getting really good performance out of this, and this should be really efficient. All right, I'll be back. I don't like the variable pitch propeller. It doesn't really function the way I would want it to work, like in an airplane. Um, that's the main reason. It doesn't scale properly with blade pitch. You should be getting more efficiency with an increase in blade pitch to a certain extent, and the way that the steam works and the way that the pistons and the turbines work, essentially as you're increasing load, you're just slowing it down. So that makes it so that the most speed is always coming from the highest blade pitch, where essentially with the highest blade pitch you'd be slowing down your production by so much that you would be going slower but more efficiently. It's and that's how the aircraft propellers work IRL and in game. And from what I'm finding with this with steam, it's just not working that way, so it's not really correct. So it works fine with diesels, but it's not really working properly with the steam system, so I wouldn't want to do that. Alright, so let's see. I'll try to see if I can get some alright, good. Are we there yet? Not yet. What's going on here? Alright, let's start trying to... Alright, there we go. So now we're starting to... So we're opening up this variable valve here, letting steam pressure through. Trying to see if I can properly meter thrust with this. Yeah, so I'm able to control my speed pretty well with this. There we go. Yeah, that's working pretty well. So doing 37 knots right now. Like, this thing's moving like stink, so... If I could get it to work properly where, like, so what you should be able to do is, if for more efficiency, you want to increase your blade pitch to maximum blade pitch. Puts extra load in your engine, slows your engine down, which works with diesel fine. The steam, pretty much, it's almost like it's got so much torque it works at any rate. It's just like... So you're just spinning it the prop up extra for no reason. I don't like that. I'd have to put more ballast in here to get that test going, but... Yeah, but still, if you load up, if you're adding more resistance because you're taking a bigger bite out of the water, it's going to put more back pressure on the system and reduce the RPS. So yes, you're going further forward per rotation, but because you're slowing down the RPS, you're doing further rotation. So at some point, increasing the blade pitch is going to make you go slower but more efficiently, and it really doesn't function that well way in game. So it's kind of funky to me. All right, I want to test something out. This could be interesting to test out. The back got very fat to me, so I kind of might want to sculpt it a little bit more, but we gotta see. I think the easiest way to test this out. you know, like eventually you get to a point where like you can just, so for example, when I was doing the piston testing, you could just keep gearing it up forever and it would just like never make you go faster, which is bullshit. Like as you gear it up, it's putting more and more resistance on you, be decreasing RPS, increasing mechanical advantage, but ultimately decreasing RPS. And so at some point you get to the point where gearing up would cause a slower speed but more efficiency, and it never got to that point. And so it's kind of funky the way it's doing it. You know, so like on my airplanes, you take off at a low pitch, high RPM setting. So I'm trying to think of the best way to talk about it, but like, so that's like the whole concept behind a constant pitch propeller in an airplane. All right, so like if you come in with a constant pitch propeller in an airplane, right? It's a screw. And so if you think of it like a screw, which is what it is, right? Let's see if I can get a picture of a propeller. It'd be easier than me screwing around. I have a good 6 days off unless I put myself back to work, so alright, so here's a couple good pictures. Could they like make one picture that's an actual size I can use? Probably not. Alright, so there's a propeller, right? And you have a certain blade pitch on this. So if we said we had two propellers, right? And there's our two propellers. And let's say they're at different blade pitches. So if we went in and, I don't know, the best way to do it is kind of, let's say 20. Is it going to do anything I've asked it to? So like you say, this one up here is at a finer blade pitch than the rear one. And the back one is at a higher blade pitch, so essentially looking something like this. And you have less of a blade pitch on this one. And so this one up front is much flatter, right? So again, you don't get anything for free. This is where a lot of people still confuse gearing, is they think, oh, if you just add a millions, billions gearboxes, you're going to magically get more speed. No. You know, so this one is, let's say it has the same size blades, but they're pitched to be less bite, right? They're going to take less bite out of the water. And so each time that it rotates, you're going a certain distance forward, right? So the way that a screw or a propeller works, which is why they call propeller screws, is for every one rotation, you go a certain distance forward, okay? And that's measurable. And so this one here with a fine bite, for every one rotation, you go this distance forward. And for this one, let's say it's twice, right? So you go that far forward. So for every one rotation with this one, with this pitch setting, you go that far forward. With every one rotation of this pitch setting, you go that far forward. So say it's twice. So if we say that is... So let's say, oh, you sucker. So let's say that's 1 meter per rotation, okay? And this one here is 2 meters meters per rotation, right? If this one's going 1 RPS, you're going to go 1 meter forward, so you're going 1 meter per second. If this one's going 1 RPS, you're going 2 meters per second, right? Pretty simple. But the problem is eventually you get to the point where as you get more back pressure with this, so you're going to get more resistance off this because it's moving more water, right? You don't get that work for free. It comes at a cost, right? Just like if you try to pick up a 1 kilogram weight, it is going to require less effort on your muscle than a 2 kilogram weight. Same thing, you're moving twice the water, you need twice the power. And so what generally happens is, again, if I asked you to curl, do a bicep curl, the more weight, the slower you're going to go. And so as we increase the blade pitch, it causes the RPS to go down. So again, if you, to do some quick math, let's say you're doing 10 RPS on this one, right? So you're going 10 meters per second, right? But if you do 10 RPS on this one, you're going to go 20 meters per second, right? So you're going 20 meters per second on this one, right? But eventually what's going to happen is your motor is only so strong. So now if we do 15 meters per 15 RPS, right? We're going to get 15 meters per second, right? Well, eventually we get to a point where we can't move that much water. So say the maximum amount of water we can move with the amount of engine we have before it starts slowing down is 20, right? So eventually, right now, right, we try 15 RPS, and we're not going to get 30 because 20 is going to start to slow it down, right? So what would happen is you'd think, oh yeah, we'll just get 30 meters per second, so yeah, of course that always works. No, what's going to happen is as we start to increase the blade pitch to a certain amount, we're not going to be able to do 15 anymore. Let's say we can do 12. Okay, so we do 12, and that's going to be 24 meters per second. So it's still faster, right? But eventually you're going to get to a point where where the math doesn't math anymore, where it's going to start slowing down the RPS. And so eventually you get to a point where, say, you can only do the max of 12. Well, over here we can keep increasing, right? So let's say we go to 30 RPS, right? And it's going to be 30 meters per second. So let me see. So 30 meters per second. So say this one, we're able to get up to 30 meters per second. Well, this one can only do 24 because of how big the blade pitch is. But this is still beneficial. I've talked about this with actually making propeller planes in game that are fuel efficient, right? So yes, you could go faster with this lower blades pitch of 30 meters per second, but your engine's turning at 30 RPS. So you're burning a lot of fuel, you're creating a lot of heat, you're making a lot of noise, right? But this one over here is going almost as fast, right? And it's only moving at less than half the amount. So you have a higher level of efficiency. And that's what constant speed propeller on airplanes is all about, is you have your max speed setting, which is a lower pitch and a higher RPM, burns more fuel, makes more noise, puts more wear and tear on your engine, burns more oil, has all these negative consequences, but the benefit is you go faster. And then you can pull your propeller back more, and it's taking a bigger bite out of the air, which is causing the engine to slow down because it's putting resistance on it. And that might say you're going, let's say you're going 10% slower, but your fuel economy is 20% more. So you're only going 10% slower, but you're saving 20% of the fuel. You're saving 20% of the wear and tear in the engine. You're saving 20% of oil burn, all this stuff. So the same thing should happen in the boats, but it's not happening with steam. It will, I think, happen with diesels as far as I've tested. So hopefully that makes sense. All right, let's see. All right, we should be up and running here. What was this test even doing, for Christ's sake? Oh, the 4 propellers. Okay. Yeah, so again, here's part of my issue with Steam is like we're still doing about the same, and I'm running 4 props. Yeah, I don't know, man. It doesn't seem like it's functioning right. Let's see what happens as the Steam builds up. We might, yeah, I don't know. It's just Steam has been a little bit OP for a while now. I don't know. Like, so this might actually be doing it all right. We might actually have the diameter. So we were doing like 37 before, now we're up to 25. Let's drop the gear ratio and we should speed up. Slowly. Maybe not. Let's drop another gear. Yeah, see, it's not functioning the way it would work IRL. Because you see, the RPS of the steam is definitely going, the turbine is definitely going up, so we are reducing load on the system. That's correct. But the reduction in load on the system should increase the RPS more. It's not scaling properly is the problem. So it makes this not work the way it would IRL. So, I don't know. Yeah, I don't know. Not gonna let it bother me. Alright. Yeah, it's just they're very OP in game, and so it makes it so that things don't function properly. You know, this also controls for that very loud sound of the turbines that I'm reserving the steam in the boilers and I'm controlling the speed with the steam. Let's do this. I didn't make a save before I started butchering the rear. I'm going to change some of this up anyway later, but... Yeah, so like this has the turbines all the way down the whole sides here. Before I had the pistons in there, so I got to play with it, see how I like it. I got to fix this graphical glitch with the water down below here. It's being funky. Don't know where it's actually having the problem. I would think that would go away with the physics flutters in here, but maybe not. Yeah, like we have this silly channel here, which is causing problems, so. You know, I could cheat. I don't know if I would call it cheat necessarily, but I could get the cost down as well by, and I might do it, trade out the battle cannon pieces for the fluid, for the, what do you call it, rocket motor, positive fluid. So put a positive fluid value in the rocket motor to get rid of the, to fix the issue with like having this, like see how many battle cannon pieces I have in here, and this thing weighs 285,000. But the problem is if I do that, then I don't really have a good idea of what's actually in there. I can't just read the value and say, okay, I gotta add 30% more or whatever. How's it going there, Trippa? Yeah, I'm missing parts. Yeah, I'm glad it's nuke again. That's I like that notion. That's fun to me to be nuke again. I'm going to add in some of the new... So we got a speed. Okay, so I wanted to get a speed. Then I wanted to throw in an electric motor just to check it real quick. God damn it, I didn't do what I wanted to do again, which was check the RPS. I think it was 38 was the last value I had, so that's fine. What's this here? Yep, we got a hole here. That's no good. All right. All right. So I want to test this with an electric motor. It shouldn't go faster because the electric motor's capped out at 19. There's another thing that the game does that IRL is different. So the benefit of like an electric motor in say a car is you can do insane RPSs on the electric motor. You know, it's moving radially, it's moving in a circle, right? So because it's moving in a circle, just like a turbine, you can get really really high speeds out of it, and it's not going to cause you any problems because it's moving centrifugally instead of reciprocating like steam pistons or a reciprocating engine like a gasoline engine. The reciprocating motion, for example, the pistons have to go up and stop and then come back down. And so it's incredibly taxing to go, you know, up and down. You start having issues like you break your what is it? Your connecting rod pins and stuff like that. So you end up breaking your connecting rod pins because as the piston goes up and stops, the pin is pulled on by the connecting rod, and then it's pushed down, the pin is pushed on again. So you get this real violent motion on your connecting rod pins. That's why like you have RPM limits, and why, for example, a motorcycle engine that revs to like my motorcycle 11,000, they're tiny little pistons and they don't go up and down very far, and they're wider, and they move very fast but very small up and down movement, and they're incredibly light. They're aluminum. They don't have much relative motion, and they're very light. You start getting into like heavy trucks, the pistons are big and heavy, so they have to move slow or else you'd break all these components, and then you have to start putting in heavier and heavier and heavier and heavier componentry, which causes all these other problems, and now you get a heavier vehicle. That's why like having heavy components in a car's engine is you start having negative returns because you start weighing down the car and screwing up the balance, where in a truck it doesn't really matter. You know, you can make a semi's engine really, really heavy and it doesn't really matter. All right, where's this? That needs to be fixed. Okay. That needs to be fixed there. So I fixed over here. There's something here. I fix this one over here, whatever that is. Okay. Yeah, so we're doing 11 knots with just electric, and so again, this is the problem with the game and electric motors. Again, is they're pretty much limited to 19 RPS. IRL, an electric motor could go very, very high in RPS, so you could you don't need gearing because you know the whole point of gearing is you've got the engine running within its band. So, like for example, the trucks I used to drive, the power band, you know, the normal operating range for the diesel was between 1100 and 1600. And so that's as far as you can go. You can't go over 1600, and you really don't want to go below 1100 when you're operating. And so you're using the gearbox to get the actual rotation of the wheels where it needs to be. With the electric motor, you can take it, and so let's say you have a truck's not really a good example of it, but let's say like you finally have a 1.5 going out to the wheel, and so the RPS of the truck is 10. Well, now you got 15 RPS at the wheel. The problem with these electric motors, we can't get that high RPS. So like with a truck, it doesn't matter. You get instant torque, and you can run the electric motor the whole range. You can't do that with a diesel or a gas motor. You need that gearbox so the wheels move in that variable range, but the engine stays within its operating range. All right. All right, good. Yep, so that was just a quick test there on just showing, like, you know, because with this turbine setup, I can get the turbines down to 4 RPS or even lower, and the output shaft going to the propellers is running at like 38. So that's where I can get my speed is there. The electric motor, I've got a whopping 19. So it's like moving half of the speed that that I'm able to get it moving like this. And then what I'm going to do is for I might as well build this system in here. Yeah, let's build this system in here. Trying to think of the best way to do this. Oh, okay. This is probably going to be the easiest way to do it. I'm getting lagged out here. Stop lagging, sucker. You see what's going on. Check the process manager, see what's eating up what. Let's see. Yeah, so what I'm going to do is I'm going to build a braking system here for when we want to go backwards. Or when we want to reverse a prop, let's put it that way. So I've been kind of getting ready to build this system for a little while. So essentially what we'll do is that will go post clutch. And then we'll have, oh, so I didn't change this. I got to fix this. Shit. I think 3131 was just working best. Let's see. What are we on here for ratios? I want to look at this real quick. All right, what ratio is on? On. Okay, so this is running it at, okay, that's running at a 9.1. We'll test this out. Shit, what's that? That's fucked up. All right. 3131, 3131. Those are fine. That's a 5.2, 5.231. Yeah, these are fine. Okay. This is fine. Okay. Yeah, that's fine. I could test that last ratio out, but what I'm going to do is I think we're just going to run this at a 3.1, so do 9.1. And then what we'll do is this will be forward, and then this one will go into... I want to make the controller for this, so 3 1s all around there. Three, 1. I want them symmetrical. If I just make them symmetrical, I'll make them symmetrical. That'll be better. All right. Yeah, let's make them symmetrical here. That's, I'm trying to see if that's going to work. That's not going to have enough force to do it. Um, Trying to think of the best way to do. So what I'm essentially trying to do is put a braking force on this where right before we try to go in reverse, it stops it. So I was doing a wheel with a brake. I don't like that. What is going on with the chat? Good lordy. Could just add a wheel, but I don't know if I want to put a wheel in there. So for anybody who's played with, is the modular engine clutch, that's more linear or not? Because I would do 2 modular engine clutches to get more linear application. I don't know. All right, let me look real quick. The chat's going crazy. Let's see. Currently my speeds are 37 knots on the surface and like 36, 37, like 50 something knots underwater. Yeah, rotor brake would be something like, so I've asked in one of the feature requests I put in was for a brake block. So just essentially make it like kind of look like a generator, and you would you just put a variable brake number to it. I lose power when I do what, Tripper? What the wheels are for? So when you're going in reverse, right, the propeller is heavy and it's still moving in one direction. And so when you try to go into reverse, you're now reversing. Now, it's not a huge deal with the turbine because the turbine's just going to be slowed down. Turbine goes backwards, the steam's going to still try to push it forwards. But ideally, what you want to do is when you're shifting from forward to reverse, you're going to detach the propeller from the output shaft of the turbine. And then you're going to put a braking force on the propeller to get it slowed down or stopped. So now the propeller is stopped, and then you reattach the turbine, and it will spin it the other direction. And so that's what you're trying to do. Now, one thing I could do would be kind of, I want to make an interesting system here. So let's make an interesting system. So I've got a couple notions here of how to make it, because again, the engineering part of it's what's interesting to me most. So let's try something. So let's try something here. Da-da-da-da. Yeah, what were we talking about, Tripper, with the, but that makes it slower or something like that? So I'm going to try something here where essentially I go. And I'm going to do this manually and then have it go. So essentially what's going to happen is, all right, so essentially what's going to happen here is when we're ready to drive, right, the turbine comes in, it's multiplied, it's going to spin up the flywheels, which do what flywheels do best. They add to the mass. And then it's going to go through a block that's either forward or reverse, and then it goes up the propeller. So what will happen is when we're going to try to go in reverse so that it doesn't slow down our turbines, it's going to detach the... It's going to detach this clutch. So now the turbine is no longer attached to the propeller or these flywheels. Then what we do is we click this into reverse. And so we have a bunch of conservation of energy. These flywheels are, say, moving clockwise. And they're moving really fast, and they're heavy. And they're moving with the propeller. And then what happens is this will go into reverse. And so what's going to happen is you have all of this mass moving to the right, clockwise. You have the propeller moving clockwise. Then it shifts into reverse. These still want to move right. The propeller still wants to move. Now it's saying, hey, propeller, move left. And so what's going to happen is the propeller is going to get slowed down by these moving in the opposite direction. And that's going to eventually get it to go and stop, or at least slow down. And that will slow it down. And then once the propeller is at a slow enough speed, it will reattach the turbine to get it moving again. So... turbines are helping a little bit. I didn't get a huge amount of speed boost. Like, I'm talking 3 or 4 knots. All right, so I'm going to play with this. Let's do this real quick. Let's save. The 30th? 30th. All right. So again, making a test bench is just going to be quicker, easier, and get this going. So I played with some of the new parts from this week's update. They're really pretty good. We were able to do like 400 SWatts with 3 of the new components on a large generator, which is pretty good. So electric motors don't really care because essentially you just turn them into big resistors to go backwards. But a diesel would care, so we can test this out with a diesel in a second. But this is just to do a real quick and dirty, try to get it set up. I didn't hook it up to anything, did I? All right, so we got 20 RPS going through. We got the propeller going now. So to illustrate this, if I click this in a reverse, because it's an electric motor, it's not a big deal, right? We have all these flywheels moving the same direction as the electric motor, the same direction as the propeller. If I click in a reverse, it's going to change the polarity in the motor, and it would just, you know, it's the electric powers fighting to turn the other way. It adds a braking force. This is how regenerative braking works. It's not a big deal, right? So we click it in reverse. Did I hook that up? I think, is it actually instantly doing it? Yeah, so it's like instantly doing it, right? Now, what would happen with a diesel, right, is if you did this with a diesel, it would stall the engine because it would stop the engine. Of course, IRL, you'd break all the parts, right? It would just be too much force to instantly reverse it, but, like, of course, we can, like, instantly reverse it here. And so what you want to do is essentially the first thing you're going to want to do before we, let's go like this. Okay, so the first thing we want to do is we want to disconnect the electric motor from this section. So we're going to take that out of the equation. So now, you see we're starting to slow down because the electric motor is no longer connected, but we have a good conservation of energy. All that extra weight from the flywheels is keeping the propeller turning. Now what we are going to do is these are turning one direction, right? This is turning the opposite direction. And now it's going to start to slow it down. All right, and now what we want to do is, that's not, yeah, the propeller's not really big enough. So let's do this. So yeah, you could do something like this, like oscillate it to get it to stop. Is another way to do it. And then what you would do is you would connect the engine back up, and now, bingo, you've got going one direction. So essentially you would disconnect, stop it, have it go in the direction you want, reconnect. And the other way you could do this is with a wheel. So, like, let's go like this. So I'm just trying to think of different and interesting ways to do this. A brake block would essentially work the best, but we don't have one. So essentially a brake block would do what we want. We have to do it with a wheel. And so instead of this, you would have like that. Actually, you know what? Go like this. Let's just do that for now. So this is essentially what you do. So like think of this as you always want your steam turbine turning in one direction, right? So you're going to start it up, connect your system, propellers turning clockwise or whatever it is. 19. And then what you would do is you would disconnect your electric motor. So now this is disconnected. This will start to slow down because of the resistance. And then you put a braking force on the propeller to stop it. And then as you increase the throttle lever again, and now it should be, it would be going the other direction because, especially for diesel, this matters. So I've been trying to come up with a system like this. The wheel's the easiest, but I don't like the wheel. It's not terrible, but I don't really like it. The other one you can do is for kind of instantaneous braking is this. Which this is better. This is what I used for my last rotor brake in my challenge build. Which, hopefully the challenge video comes out soonish. I certainly get the, how much work it is, but it's also like, you lose excitement when the, takes a month or two to get the challenge out. So like what you do is one of these goes forward and the other one will have a reverse option. And you go like this. All right, that's going. We detach the engine, the motor from there, and it stops it. And now this is in reverse. And so now if we go... okay, no, those just need to be disconnected. Yep. And then you detach. That's how my rotor brake works on my latest helicopter. And so it stops the propeller instantly because what it's trying to do is you got the power going in, and once it gets up here, it's like a shaft going one way, shaft going the other. And so they meet in here and they say, oh shit, can't move anymore. And then you can see how that works as well to stop it. And you need this for, like, if you ever hear my boats in game, sometimes when I shift into reverse, you hear the starter go, and that's because it's trying to turn the propeller backwards, so it slowed down the engine, and then it causes the engine to get below the 2 RPS, so the starter kicks on. So I'm trying to see if these are linear too. So like if I went, let's say I went to 50%, is this linear or not? Trying to see if these are linear. I don't know if they are or not. Yeah, so that's not really doing shit. These are not linear. Yeah, like that's not linear. Likely too, the power out of this electric motor is so high that it's, again, this is part of the problem with the way that this works in game. It's not really realistic. Yeah, water resist slows it even further. Oh, I just saw Rasmus' comment. Yeah, we'll do a quick, we'll throw an engine in it. Part of the reason I didn't want to do the gearbox 1, -1 at first, I didn't want the props instantly stopping. I wanted them to slowly stop. But now I don't really give a shit, so. You know, originally I was going to have it slow down slowly. That was part of the, you know, got to be a little bit more natural and have some time difference between when you actually try to reverse it, but I don't give a shit. So essentially what we're going to do here is we're going to go in and prop break. All right, so let's see. Essentially, when the clutch is 0, that's the easiest way to do it. Clutch 0, prop break. I'm trying to think here. Could also just do a pulse through reverse, but that's not going to stop it going into forward. Let's see. We'll try this. This might not work. We'll try it. Okay. Could you zoom there, stupid ass mouse? Thanks. All right, so we're going forward now. Let's go in reverse. So you see it stopped it. It still stalled the engine out, but you see it stopping the propeller. I put a 0 on the clutch. I don't know why that didn't do it. I did got it where press the space bar, it does a 0. I thought that also zeroed out the clutch. Clutch 0, 3.25, less than that. Okay, that's good. When's the starter kicking on? Go like this. This should be connected there. All right. So it's moving to the right. Press the space bar. Should stop it. Yeah. Get that working. Let's save this real quick. Yes, that works. Let's see. When I get off the drive system for a little bit, it's working. It's working well. I would have rathered it be pistons, but it's yeah, I've got what do you call it's in there? I've got turbines in there now, which I kind of like. They're not bad. It's just not exactly what I wanted at first. Turbines are more what they should be, but the pistons are problematic a little bit. Couldn't get the speeds I wanted the piston. It wasn't far off. I was doing like 24 to 28 knots. I'm now getting like 10 knots faster, which I like. So let's go ahead and dick around with a crane for a little bit. So the crane's working. The crane works fine. I showed everybody earlier. I was having problems with this door putting it in here, so let's screw with this. I don't know why the door was acting up, so let's play with this. Okay, I was doing this at work, so maybe it was just something going on when I was there. I've got a good 6 days off too, so we'll get some motorcycle riding and play some game. See, this is the type of thing, if I had enough days off, I could actually run a build challenge, but I don't know if I want to do that right now. Where's that hitting? What is hitting that top there is the question. What is hitting the top there? Oh, it's the hardpoint top. That's part of the problem. Okay. So that's where that is. All right, so it's got to be like there. All right, so that's in there, and then we got to fix the bottom layer's fine, I guess. Bottom's fine. And then I got to work the door. All right, screw with this for a little bit. All right, so this was the problem I was having. It's hitting something. I don't get what the hell it's hitting. So maybe the hinge is in the wrong spot. I gotta look. The hinge looks like it's in the right spot. It's lining up. You see, it lines up there. It lines up there. This hinge just isn't coming up right. I don't get why this hinge is having problems. Yeah, I don't see what the hinge is having a problem with. Make sure the steel's not actually grabbing. Yeah, what the fuck is this hitting? I don't know why this is hitting it. Yeah, I can't even get that to come up at all. Like, this room, that doesn't need a seal as part of the thing, so. See if it's a hinge problem. You see that right off the bat here in a second. Screw with that for now. I just stick with that later. I'm just trying to check proof of concept, see if this works. All right. something with the hinge. What happened to the hard point? The fuck happened? Oh, I did the wrong one. This one. Yeah, we're gonna have hit problems with that door, so I think having it in this cubby is gonna cause me problems. I think having it in the cubby is gonna give me just a ton of problems. Putting on the elevator is an option. Play with one on the elevator. So I don't want to take up too much elevator space because then the makes it hard to land something on here, so I gotta be careful of that too. I should have bought stock today. I got symmetry on shit. Alright. Stop. Undo symmetry, please. Thank you. Alright. Sometimes you can make a gangly looking thin crane look good, sometimes you can't. So okay, that's wrong. Alright. Let's try this first and see how this works. let's give this a quick dry run. You know, the other crane was good and strong and worked fine. Let's play with this one. All right. This is one thing is I still think this is something they should really prioritize is making it so we can use alternate paint to paint the diamond, and then you could hide weight. It would be fan-frickin-tastic. All right. Will it lift the container? The old one lifted the container, so we'll see what this one does. But the old crane lifted a container. We got some pretty dangly cranes that have no problem, so we'll see what happens. Yeah, it seems to lift the container, no problem, so. Seems to do its job. Let's see. It's rotation. I gotta go real slow, so. But that's on the elevator, so there's benefits and there's drawbacks to having this on the elevator. Alright, good. That's good progress. Oh yeah, this thing weighs, the whole submarine weighs 285,000 kilograms. So this is so inconsequential compared to that. It's like 1% of the total overall weight. Stop. What's that? That is 27. Okay. 27, and we are 1, 2, 3, 4. So I can go 23 at most. Shit, that's got to be a slider, so that screws me a little bit on what I want to do. Let's see. I hooked the up down. I must have. If I didn't, I'll fix it. It's hitting now. Oh, it's weird. Why is that hitting? I thought I measured. Did I screw up the measurement? Did I screw up the measurement? I must have. Oh, fuck off. Make sure that's connected while I'm at it. Yep, alright. Has everybody seen my people elevator? What is it? Is this hitting something? Why is that not flush? I don't know. It's not flush for some reason. Alright, let's see. I didn't hook the goddamn container up. I'm gonna go get a rope. So, I'm having to load this friggin' thing again. Watch me already have a rope on my character? Probably not. Yeah, there it is. That should handle all of our container needs, so. Pretty damn compact. See how much we list. Shouldn't list too much because it's high, but it's also this sub is just incredibly heavy, so. Yep, sub barely moves. Sub's very, very heavy. This is the thing with ballasting, is like where a lot of people don't do it, is like get as much buoyancy as you possibly can into your ship, and then add absolutely a ton of weight down low, just like a real ship. And the the consequences of a single container, which is like 1,300 mass, the whole submarine weighs 200 and something, like high 200s, 1,000 kilograms. So like I said, it's like 1%. It's like less than 1%. It's like half a percentage of what the it is. So then you start putting it on a long crane. Yes, it does increase the effective weight of it by putting that out on that long lever arm, but it's really not all that bad, you know. And that's where like the people build their boats like their little styrofoam things, and that's why they have problems. You know, it just looks like a big boat. It doesn't actually function like a big boat, having huge amounts. Now, it's easier with a submarine because I want this to sit low in the water so that I don't have to fill so much water in there. But I also, my ballast tank is full right now, I think. Yeah. So, yeah, so kind of like the plan here is, let me see if I can go stop it and get it where I want it. Let's see how easy this is to operate. So let's go to 0. Let's bring that in negative 0.01. Go down. So like you would take the container off the dock, you put it on the elevator, and then you should be able to lower the elevator and bring a couple inboard. And then there's going to be a gantry crane inside in here, and that will be able to move it inside. But also, you should be able to use this little crane inside. Yeah, so that's a good proof of concept there. That works pretty well. All right, I'm going to save this up. And I think we'll jump off. So I should be around for, should be off the next 6 days unless I pick something up. So should be able to do a bunch of streaming. But thank you guys for watching. If you liked the video, give it a like. It was good to see everybody. Good to see Owl and Sergeant and Rasmus. And who else stopped by? Tripper. It was good to see Tripper. I haven't seen Tripper in a while. Good to see everybody around. I didn't miss anybody, did I, who was in the chat? Nope, I think I got everybody. But it was good to see everybody. Thanks for watching. Should be, might even stream some Tarkov or something later tonight. But thanks, guys, for watching. If you liked, give it a like. If you're new and you enjoyed it, subscribe. And I'll see you guys in the next one. Bye.